Hi there, folks, and welcome to this week's Word Solutions for the Daily Rigour, issue number 250. So that's officially a quarter of the way to 1,000 editions, and it only took us 5 years or so, didn't it? Anyway, on to our health story first of all. So it turns out that these new COVID-19 variants are going to be given Greek alphabet letters for their names instead of naming them after the places they were discovered. So the first variant discovered was in the UK, Kent. But we want to know what letter will the Indian variant now be known as. So gives us a wee opportunity to explore the Greek alphabet, which is used an awful lot in maths, particularly in formulas, because a lot of mathematics was developed in Greece a long, long time ago. So unlike the English alphabet, the Greek alphabet only has 24 letters in it. So the UK Kent variant is now going to be known as alpha, the first letter of the Greek alphabet. So the second variant that was discovered was the South African one, which will be beta. And after that, it was a Brazil variant, which is now going to be called Gamma. And then it was the variant discovered in India originally, so that's going to be called Delta. So we're hoping they won't discover a 10th variant, but if they did, what letter will be assigned to it? Well, it's just the 10th letter of the Greek alphabet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can clearly see that it will be assigned the name Kappa. Anyway, on to our travel stories. So this is a very humorous one, I thought. A teacher got in the wrong flight meaning to travel to Belfast but ended up in Gibraltar. So how far is it from Manchester to Gibraltar? Well, altogether it was 2,564 miles travelled. So we can take off the distance from Manchester to Belfast first of all, and this gives us 2,396 miles, but that was of course to Gibraltar and then back to Manchester. So we need to divide that by 2, so it's a total of 1,198 miles. So on to our UK story. So the first privately run prison is going to have no bars or windows and river views, and rather than the usual K-shaped formation, and the reason why they were designed like that was because you could put a guard right in the middle and they could actually view all the cells really quickly. But instead they're actually going to comprise of these buildings in the shape of X's. So of course X is the most common variable in maths problems, so we've got a few maths problems here where you have to try and find the value of X. So first things first, we've got a square with an area of 36 millimeters squared and a perimeter of X. So what is the value of X? Well, first of all, we'd need to find the length of the side of the square, and to do that we can square root the 36 to give us 6 millimeters. So in the square, if you've got a length and a breadth of both 6, 6 times 6 does give us an area of 36 millimeters squared. So for the perimeter, to do that we have to add up all the sides. So if you've got a square, you've got 4 sides, which are 6 millimeters in length. So for the perimeter, which is our variable X, we need 4 of these sides of 6. So 4 lots of 6 millimeters. So that will be a perimeter of 24 millimeters. So part B, we have to now solve this equation for X. And to solve an equation, of course, the aim is to get X on its own in the left-hand side. So we're going to get rid of this minus 5 first of all, and to do that we're going to add 5, but of course what we do to one side of an equation to keep the balance, we've got to do to the other. So we'll add 5 to both sides. So minus 5 add 5 gives me 0, so that means I'm just going to be left with 8x on the left hand side. So on the right hand side we've got 19 add 5, which is 24, and then to find the value of 1x, I'm going to divide both sides by 8, because 8x divided by 8 is just 1x, and 24 divided by 8 is 3. So in our second one, x equals 3. So part C, we have to find the missing side in this right angled triangle. So believe it or not, we're going to be using a bit of Pythagoras theorem for this. So you might not have seen this before, but Pythagoras theorem states that the area of the square in the hypotenuse is equal to the area of the two other squares with lengths of the two other sides. So in other words, if you drew a square on here and you drew a square on here and here, these two smaller squares would fit exactly into this larger one. So the hypotenuse squared is equal to the two smaller sides squared and added together. So to use Pythagoras' theorem, we can say that x squared is going to equal 4 squared add 3 squared. So that's going to be 16 add 9, which is 25. Now that's not the value of x, that's the value of x squared. So to get the value of x, we need to square root this 25, similar to what we did in the first example. So the square root of 25 gives us a length of the side of 5 centimetres. So that's enough about x. Let's look at our sports story this week. So Mo Farah finished a wee bit short of the time required to qualify for the Tokyo Olympics. So by how many seconds does he need to improve his time? So he took 27 minutes 51 seconds, but he needs to achieve 27 minutes and 28 seconds. So because the minutes are the same, we can just take the seconds away from each other. So he needs to improve by 23 seconds. So what must the average speed be to end up with a time that's going to qualify someone for the Tokyo Olympics? So we've been asked to work out a speed, which is of course distance divided by time. The distance of course is 10,000 metres because it's a race. Now if our units have to be in metres per second, our time will have to be in seconds. So we need to say how many seconds there are in 27 minutes and 28 seconds. Well, there's 60 seconds in 1 minute. So we're going to do 27 times 60 to change 27 minutes into seconds. And then we'll just add that extra 28 seconds at the end. So when we do all that, we're going to be dividing by 1,648, which means the average speed to qualify for Tokyo must be at least 6.1 metres per second. And there you have it, folks, our word solutions for this week. We hope you enjoyed solving these problems. Stay tuned for next week's edition, when we're going to be looking at more stories from the news of the week and the numbers behind them. But in the meantime, thanks for watching, and bye for now.